and I'm going to be walking you through your Integrated Science A Project 4. It's found in lessons 16 to 20. So let's go ahead and work through this. This will just help you understand what we're expecting and what you need to do. So first thing, on all your labs, you want to have the lab instructions. That's what you see as you scroll through the class. Okay. And then you want to also have the lab handout. Now the lab handout needs to be filled in. Okay, they look similar, but they are different. Lab instructions give you some instructions about what you need to do. The lab handout is what you're going to turn in lesson 20. So you want to save the lab handout to your desktop. Now your teacher may have also included a Word document that is exactly the same as the lab handout that you have in your class, but it may be easier to fill in and work with it. So either way, use the one that you get through the lab handout button, or use the Word document one that is provided for you. It is good to have either two tabs or to save them to your computer so that you can read the directions and instructions as you fill out the lab. And I'll show you as we move through why that's important. Okay, part one. There are 5 parts to your lab. So we're going to look at part one. Part one says to write some common names for these following excuse me, following substances. Now, you're going to look those up and find out the names. If you look in your instructions, it gives you a little more detail. And then you're going to answer these questions in part one. Were any of these substances that seem to have similar and common names? And tell why you feel that way. So after you look up the common names for these substances, because these are the chemical names, you're going to see if there are any that are similar or almost the same or maybe even the same. And then tell why you felt that way. Then you're going to name one property of that substance. Okay, so as you're looking them up, be sure to look at the properties so that you can name one property of that substance. Maybe what it does, how it reacts, maybe even what it looks like. It doesn't have to be any particular property, but just one property. And then one use for that chemical substance. So you're going to, in your research, want to look at the common names, a property, and a use for those substances. So have those in mind as you go through and get your answers, because question 2, 3, and 4 are going to ask you for each of those. Okay? So that's part 1. Part 2 has to deal with chemical equations. You have 2 equations. This is reaction 1. Okay, you have acetic acid and sodium bicarbonate yielding carbon dioxide dihydrogen oxide plus sodium and acetate. Your second reaction is calcium chloride, sodium bichloride equals carbon dioxide, calcium carbonate, sodium chloride, and dihydrogen oxide. Sounds like a lot. Well, we're going to review briefly, and you can go back to lesson 16 to help you understand the types of reactions, and I'm going to show you a quick reminder of how to balance the reactions, okay? So, question 1 is the equation for reaction 1 balanced? And if so, explain your answer. So you're going to look at reaction 1, say if it's balanced or not, and why. Your second question is looking at reaction 2. Is it balanced or not? And then why you feel it is or isn't balanced. And then if it isn't balanced, you need to tell how to balance it, okay? So one is balanced and one is not. The question 3 that you're going to find in part 2 is what kind of reaction do you think reaction 1 represents? And what kind of reaction do you think reaction 2 represents? One thing students miss is that if you read the instructions carefully, it says you need to use these following reaction types: synthesis, decomposition, single repletion, double repletion, or combustion reaction. So you're going to want to go back in lesson 16, look at those types of reactions, and then look at these reactions and decide which one best describes reaction 1 and reaction 2. Again, always go back to your lesson. Always go through the instructions carefully to help you be successful on these projects. Next slide is going to help you with balancing equations. You may have forgotten, we did go over it in the lesson, but briefly. So we're going to take a look at a simple reaction, but remember, the principles are the same, whether it's complex or simple. So apply these principles to solve your question. It says first thing is you're going to count up the atoms of each element on each side. So we're going to count up how many magnesiums do we have and how many oxygens we have on each side. So you can list your atoms or your elements, and then on this side you'll list how many for this side for the reactants, and on this side how many are in the products. So let's take a look. On this side we have, say we have 1 magnesium, okay? In this side, we have 1 magnesium, so we have the same number of magnesiums on both sides. Good. Okay, let's look at the oxygen. We have 2 oxygens on that side because you have this lower or subscript of 2. On the other side, we only have 1. So this is not a balanced equation. For an equation to be balanced, you have to have the same number of atoms for each element on both sides of the equation. So although the equations you're looking at are a little more complex and have a little more elements, carefully count the number of atoms of each element, listing it on both sides so that you can compare the reactants to the products. And if there's the same number on both sides, then it's balanced. If there is a difference, then we need to balance it. So this one has a difference, so we need to balance it. How do we balance it? How do we get magnesium to be magnesium plus oxygen to be balanced? Okay, we have an imbalance here. So what we're going to do is the numbers aren't balanced, so then add big numbers to make up for any shortages. And that's a big number. This is what we call, these are subscripts, and those you cannot change, but these are coefficients, and you can change those. So if we make this 2, then we have to change this to 2 magnesium and 2 oxygens. Okay, so then our oxygens are the same, but now our magnesiums are going to be different. So let's see what happens here. So now we have 2 magnesiums and we have 2 oxygens. So now the oxygen's okay, but the magnesium is wrong. So what can we do? We can add another coefficient to the magnesium, to the magnesium to make it 2 here, and that would give us a balanced equation. So if we put a 2 here, then we would change this to 2, and our equation will now be balanced. So we'd have, oops, that should stay there. So we'd have 2 magnesium on both sides, 2 oxygen on both sides. So that's the key. It's the conservation of matter. We need to keep it balanced. Okay, if you need help with that, please contact me or your teacher. We'll be glad to help you balancing the equations or checking to see if they are balanced. Part 3. That was part 2, just those equations and those questions. Now part 3 is actually doing the experiment. Follow the directions in the lab instructions, not the handout. The handout does not have any of the instructions. Here are the instructions is what to do. Okay, here is the part that you have to fill out. You're going to have to fill out for reaction 1. There's 2 of them, reaction 1 and reaction 2. You're going to do 2 reactions. You're going to keep track of the change in temperature as you combined your substances, okay? And record those changes in temperature. Now, please note, if you have trouble getting the materials, you can contact your teacher. They have some data for you to use, and you will just need to interpret the data. It may be in the teacher notes, or you may need to actually call your teacher to discuss it. But you will fill out all of these two tables. There's one for reaction 1 and one for reaction 2. Then you're going to be asked to find the change in temperature. So to do that, there's another little chart in part 4 for the experiment. It says the initial temperature. So this would be the temperature of substances at the very beginning. You run a little bit of test while you determine what the initial temperature is to make sure it's not going to fluctuate before you actually start the reaction. And then you give the final temperature. That's the last point at which the temperature changed. So you may need to leave the temperature sit for a while or to make sure it changes or stops changing. And then you're going to subtract the final temperature from the the initial temperature from the final temperature. So you have, here's your little formula. T2 is final, T1 is initial. You're going to subtract your initial temperature from your final temperature. Now, in one of these reactions, your answer is going to be positive. Your initial temperature is going to be, your final temperature is going to be higher than your initial. But in one of these reactions, it's going to be the opposite. And you're going to end up with a negative number. So be sure you use your temperatures correctly. And if the final temperature is less than the initial temperature, in other words, if your initial temperature is 20 degrees centigrade and your final temperature is 18 degrees, then you're going to have a negative 2 degrees for your change in temperature. So be sure you note any negative charges, okay? Once you've done that, then you're going to evaluate. And again, review lesson 17 to help you with these questions. You're going to describe your experience in performing this experiment, okay? How did it go? Did it go well? What problems did you have? Would more trials have helped you? Which reaction had a negative temperature value? So which one is it? Is it 1 or 2? And is the reaction endothermic or exothermic? Go back to your lesson and understand endothermic and exothermic. For each reaction, describe 3 ways you could tell a chemical reaction was taking place. Review what we look for to decide if a chemical reaction has taken place. It could be something like bubbles or color change, whatever, but you want to have 3 of those for each individual reaction. Which reaction took place at a greater rate? Okay, which one changed temperatures faster? Okay, and what factors could have caused any differences in your reaction or may have been a problem in the reaction other than the changes in temperature? Then once you've got that all filled out, make sure your answers are saved to your document, and then in lesson 20 you will upload this document. If you have questions, please contact your teacher as soon as possible. If you're having any difficulties with this, contact your teacher for help. Thank you and have a great day.